second class, and this is kind of first class for thin walled structure or aircraft structures or flight vehicle structure. Okay, so guys, if you see the official syllabus, if you see official syllabus, uh, you can see they have mentioned characteristics of aircraft structures and materials, torsion, bending, and shear of thin wall sections and loads on aircrafts. So that is what flight vehicle structures syllabus, and there are some special topics like compatibility equations and air stress function. Okay, so all these things we will be covering in this subject. So actually, what is the flight vehicle structure? We also called it as aircraft structures. Okay, so what are the fundamental requirement of flight vehicle structure? Can anyone tell what are the fundamental requirements of a flight vehicle structure? It always require high strength to weight ratio, or you can say strength to weight ratio must be high. Same time stiffness to weight ratio must be also high, right? So how these requirements are fulfilled? Can anyone tell how these two requirements are fulfilled in flight vehicle structure or aircraft structure? Anybody? We use what to fulfill these requirements? uh, Strength to weight ratio high and stiffness to weight ratio also. It's not always composite materials, Mr. Nishant. The first requirement we use thin walled structure. Okay, so to you know constrain the weight, okay, optimize weight. Okay, so thin walled structures are used. Okay, so in basically aluminum alloys, which are lightweight structure, right? Which are lightweight materials, right? Density is less. So usually in aircraft structures, aluminum alloys are used, and nowadays composites also used. Okay, because in composites you can have less thickness and high strength, okay, in the required directions, okay, where more stresses are coming up. So the basic or fundamental requirements of flight vehicle structure or aircraft structure is what? High strength to weight ratio and high stiffness to weight ratio. Now guys, what do you mean by high stiffness to weight ratio? Can anyone tell what is the high stiffness to weight ratio? Hmm? Anybody? High stiffness to weight ratio means what? Hmm? See, you cannot have, you know, um high deformation, right? You cannot have, because your components are large, right? The lengths are more. You cannot have very high deformations, right? But still, if you see the deformation of wings, it's a significant, right? So since components are long, right, slender, right, so you have to have high stiffness, so there is less deformation, right? Ground clearance and all, right? Can you have a wing which is like under deformation touching ground? You can't have, right? Such wings. Yes or no? So you same time less thickness but high stiffness. Okay, so which is a very important requirement. Okay, in aircraft structure. Okay, now since we told we usually in a flight vehicle structure to optimize weight or to restrict weight, we use thin walled structures. So what is the thin walled structure? Can anybody tell what is the thin walled structure? So a structure is known as thin walled if its thickness is very less compared to other dimensions like width, length, or depth. Then structure is known as thin wall structure. Okay, and usually thin walled structures are what kind of problem? Thin walled structure, a plane stress or plane strain problem? You guys have read, right? Plane stress problem, plane strain problem, right? So usually thin walled structures are plane stress problem. Okay, plane stress problem. So now what is the syllabus? Okay, as per like how I define the syllabus, that was the given gate syllabus. So usually I define syllabus: first basics, some basics, engineering mechanics basics like cross sectional property, then we see thin walled approximations, and then thin walled idealization. Okay, so in today's class we will cover these three things, and then we study unsymmetrical bending, then flexural shear flow and shear center, then torsional shear flow, and the last flight vehicle structural components. In that I will discuss about components, different components, then material used in those components, and their functionality or the kind of load beared by those components. Clear? So that's what the syllabus. And sixth, you guys can add that special topics, which is what? Compatibility equation and this Airy stress function, right? Actually, this is part of your strength of material. Okay, usually when I used to teach, I used to cover that in strength of material itself. But since Rahul sir is from Mac background, so I usually cover this topic in this thin wall structure or aircraft structure. So compatibility equations and Airy stress function. Okay, guys. Now, what are the reference books we guys use for this? We use Aircraft Structures by TSG Magazine and Aircraft Structures by Citizen. Both books are available in book drive. Okay, in book ebook drive link you guys have, right? So these books are there in book drive. Okay, and what is the weightage of this subject? Aircraft structures or thin wall structure, including compatibility, air stress function, everything. If you include, it will be like 4 to 6 marks. Okay, and if you cover, if you just take other than this compatibility equation and air stress function, usually it is 2 to 4 marks. Now, guys, here if you see in the gate, weightage is less. But when you go to industry, guys, tell me what is the weightage of this subject? If you go for job, either in government job or if you go in mainly in PSU like DRDO, HL, okay, um, these are the two main PSUs, right, which works on different flight vehicle structures. Or if you go in this any private MNC job like in structural analysis area, mainly in Airbus, Boeing, or any service industry. So, which is most important subject? This aircraft structures will be one of the most important subject. Okay, where interviewer will ask you guys question, and also in day-to-day activity. Have you guys heard about something called hand calculation? Have you guys heard about hand calculation? So in aircraft or aero structure, lot of hand calculations are done. What is the technique used for hand calculation? Yesterday we discussed, right? What is the technique used? The strength of material concepts, SOM concepts, okay, are used in hand calculation. Okay, and for what structure? Aerostructures like fuselage, wing, okay, and different components. So there the here this unsymmetrical bending, flexural shear flow, shear center, torsional shear flow, all these are extension of strength of material concepts. Okay, because unsymmetrical bending, again bending come in picture, right? So the basics are derived from your strength of material only. So whatever we are going to study in this subjects, either it is directly used in industry in terms of hand calculations, okay, or if you go for any interview, there definitely they ask many questions along with topics like basic elasticity, or if you take bending theory, okay. So these are SFBM diagrams and all comes under bending theory, right? So those are asked frequently, okay. Now, any doubt in this syllabus part, references, weightage, anything clear? Okay. Now, let's start the first part, cross sectional properties. So, all of you know, right, from engineering mechanics, what is centroid, guys? What are cross sectional properties? Can anyone tell what all cross sectional properties? Pragati, usually I have referred TSG magazine, but I will tell you guys, don't refer any book. Just refer my lectures and my notes. Okay, because thin walled structure, if you learn in your engineering as an engineering subjects, you have to solve so many lengthy questions, right? But in gate, the questions are not lengthy. They ask very simple question. You need to understand fundamental correctly, okay. So I'll not suggest to you guys to refer any book, okay. If you have time, then you can explore bit, but rather sticks to my lectures, my notes, and PYQs, which I am going to solve every almost every question, and then you guys can attend mock exams and all. But still, the magazine books complete solution is available, okay. So you guys, like I have put some assignments where the questions are taken from magazine, and for that solutions also available. But the problem with thin wall structure, lot of calculations are involved, particularly to find cross sectional properties. Yes or no? Have you guys, how many of you have done this course, aircraft structures, in your undergraduation? Yes or no? So you guys can answer in poll. So there are people who have not done this course, okay. Don't worry, guys. Those who have not done even course, not to worry, okay. Okay, all right. So 80% people have done this subject. So you guys found this subject easy or tough? Hmm? You guys have found this subject easy or tough? Easy. That's good to hear. That's good. Mathematical. Yeah. Moderate. Okay. Lengthy. Okay. That's fine. Good. So we will see. Yeah. So what all cross sectional properties you guys know? More calculations are there, and you need to know properly sign convention. Formulas are also lengthy, but it is not very tough, okay. These subjects have very limited number of formulas. It is not like SOM. In strength of material, there are so many topics, so many formulas, but here very limited number of formulas are there. But you need to understand, especially mainly unsymmetrical bending formula and shear center formula, remaining things are simple. Okay, so what are the cross sectional properties? You guys know, one I have mentioned, centroid. Apart from centroid, what other cross sectional property? Area moment of inertia, exactly. So in majority of the thin walled problems, you have to first find centroid and then area moment of inertia. So there lot of calculations are involved. So what is the centroid? So centroid is a point where area of the cross section is concentrated. The entire area of the cross section is concentrated, or you can say the first moment of area about centroid is zero. Right? So that is what the definition of the centroid. What it means, see, suppose this is the arbitrary cross section. So there will be one point where the entire area will be concentrated. Okay, so that point is known as centroid. Okay, this point is known as centroid. Now guys, for symmetric cross section, the centroid acts on the point where the area of symmetry intersects, right? So simple cross sections like regular shape, like rectangle. So where the centroid will be, like if you join these diagonals, so this is what centroid, right? So this is what, where your axes of symmetry intersect. Same way for square, okay, and for circle. So easily you can find, centroid. Now guys, when we learn simple bending, what kind of cross section we usually use, guys? In simple bending, usually what kind of cross section you have? In beam, right? Usually rectangular beam, circular beam, right? Or square beam, right? Sometimes I section is also there, right? So for I section also, if you draw I section, there can be a double symmetric I section, right? What is the shape of spar? What is the shape of spar? Spar. Where spar is used, guys? Where spar is used? Ritam? It is used in wing. What kind of load spar carries? Jayprakash, Sahil, Sonu. What kind of load spar carries? So spar carry mainly bending, okay, and torsion. Mainly bending loads are carried by spar, right? Okay, so spar. So in spar also you can see it's a doubly symmetric. So what is the centroid? Here. Okay. So for any simple regular shape, you can directly find centroid. Okay, where at the intersection of symmetry of the axis. Okay. Now guys, there can be another kind of section which is known as antisymmetry section, right? So what is the antisymmetric section? You can see this is a Z section, right? In this Z section, you can see this point is what? Point of antisymmetry, right? This is the point, and this point is known as what? Point of antisymmetry. So this point of antisymmetry will be what? Your centroid. Okay. Now guys, you can have some arbitrary shape body, okay, or arbitrary shaped cross section. So in that case, how you find centroid? You can have any arbitrary shape body, okay. So in this case, you have to use integral formula. So what is your x bar? The x position of centroid, so it is integral x dA upon integral dA. Same way, y bar, it is integral y dA upon integral dA. Okay, now guys, you want this is about arbitrary shaped cross section. Now guys, suppose I have a cross section, okay, which is not arbitrary shape, but it is not a symmetric cross section. Like suppose I have a L section, okay, or T section. Can anyone tell how we can find centroid? You guys have done, right? For L section, for T section, for Z section, how we can find? We can find using summation formula, right? So centroid for a regular body. This is what regular shape body, but these are not symmetric cross section. So we can use summation formula. So my x bar is what? Sigma ai xi upon sigma ai, and what is the y bar? Sigma ai yi upon sigma ai. So you all know these basics, right? So let's move on quickly. Now the next, what is the first moment of area? Okay. So first moment of area means what? You know integral y dA. So area is dA. Okay. Suppose this is what my some arbitrary shaped body, and I am talking, this is my small area dA, and here my centroid. So what is going to happen? If you take first moment of area, which is y dA, and if you integrate for this whole body, what it will be? What it will be? It will be 0. It will be, okay. So that is what first moment of area. Now the next cross sectional properties is what? Area moment of inertia. So what is area moment of inertia? It is second moment of area about centroid is called area moment of inertia. Okay, second moment of area about centroid is called area moment of inertia, and it contributes to what? Rigidity of the section against applied load. So again, what is the rigidity, guys? Can anyone tell what is the rigidity? What is the rigidity? Or what it resists? What resists by rigidity? Resists what in a structure? It resists deformation of the body. Okay, so you guys may be knowing, right? AE. What is the AE, guys? AE is what? AE is what? Axial rigidity, right? Now what is the A, guys? What is the A? A is the area, right? So area is a cross sectional property, right? Now guys, what is the GJ? What is the GJ? What is the GJ? It's a torsional rigidity, right? So what is this J, guys? It's a polar moment of inertia, torsional constant, right? So again, J is cross sectional properties. What is the EI? Flexural rigidity, right? Flexural or rigidity, right? So what is the I here? In flexural rigidity, what is the I, guys? What is the I? It's a area moment of inertia. right? So here we are going to talk about area moment of inertia, because we are going to discuss further unsymmetrical bending, and where always this area moment of inertia come in picture. Now, what is the area moment of inertia? It's a second moment of area about centroid. Okay, now guys, if you take again a arbitrary shaped body, then how we find cross sectional properties? One thing, tell me guys, about which point always we find area moment of inertia in simple bending. You know what is the formula? Simple bending, sigma equal to m upon I into y. Now tell me guys, I is found about which point, and from where y is measured? Pragati, it's not about neutral axis. I is found about to axis, okay, which is passing through what? Centroid. I is found about an axis passing through centroid, because neutral axis passes through centroid, right? And y is also measured from where? Y is measured from always centroid, okay, because neutral axis passes through centroid. Now this I is about x axis or y axis, we will discuss everything, okay. What actually this formula? Now tell me guys, if I ask you guys further, okay, let me draw a beam, we can discuss in a quick way. Okay, quickly we can discuss. Okay, let me draw a beam. Now guys, okay, now this formula, I am applying one load, okay, on this beam in transverse direction. Okay, let me apply UDL. Okay, now guys, tell me, in this formula I am writing this as a z axis and this is x y. So in this formula, sigma equal to m upon I into, okay, let me write y. Now sigma is in which direction? This bending is stress is in which direction? What, Sonu? Did you study SOM? Why this clarity is not there? See, bending stress is what? A shear stress or normal stress? Sonu, what is this XY? XY is a cross section, right? What is the XY? It's a cross section. Okay. Now, what is the Z? It's a longitudinal axis, right? So, what actually sigma? It's a normal stress, right? So, in which direction it should act? So, no. Now, you tell so no in which direction it should act. Normal. Normal is what direction? What is the normal direction here? Is it X or Z? Exactly. So this is basically what? In simple bending, this is sigma Z, right? Or you can say sigma ZZ. Now tell me guys, When you applied this UDL, what will be your moment? Will it be mx or my? So now what will be this moment, mx or my? It is mx, right? So bending moment, see this vertical load will create a bending moment about x, right? So it is mx. So this is mx. Now what will be your moment? If bending moment is applied about mx, so I will be taken about what, y axis or x axis? Hmm? Y will be taken about what, x axis or y axis? See, I will be taken about what? I am talking I, not y. I will be taken about x axis or y axis. So, see, the moment is applied about x axis, so I should be taken about same axis. So, you can see in simple bending also, when you applied load, okay, in vertical direction, you have a bending stress or normal stress in z direction, and for applied moment about x axis, so it is z, you can say xx and y. So easily you guys can remember this formula, right? Okay, we will discuss more when we move to unsymmetrical bending. Again, you guys have heard about compound bending, right? This sigma z can be, right, it is mx upon ix into y plus, you can have what guys, can anyone tell? It will be what, my upon iy into x. Clear? You can have, right, this is known as compound bending, right? You have bending about both the cross sectional axis. Okay, so that also we will discuss and we will understand, okay, how these are coming. Okay, so further we were in moment of inertia, area moment of inertia. So my ixx is what, it is integration y square dA. My second moment of area, right, about x axis. So that means what is the distance of area from x axis? It is y. So it is integration y square dA. What about my Iyy guys? It is integration x square dA. Guys, many people do mistake and sometime I also do typo. In calculating ixx, people write what, integration x square dA, which is wrong. Okay, so ixx is what, integration y square dA. Iyy is what, integration x square dA. The one important here, another area moment of inertia, which is known as what, product area moment of inertia, ixy. So what is the ixy is what, integration yx dA. And where it comes in picture, when we go to unsymmetrical bending, we will see in that formula ixy come in picture. Okay, so that is known as area, product area moment of inertia. Now this ixx and iyy always what, positive. Okay, but this can be either positive or negative. Your product moment of inertia, either it can be positive or it can be negative also. And this is always equal to 0 if you have any one symmetry. Like if you have a cross section and in that cross section at least one symmetry exists, then this product moment of inertia is 0. Means suppose you take T section. Guys, tell me, is it symmetric? At least one symmetry is there, right? About which axis? About y axis, right? So product moment of inertia will be 0. If you take C section, guys, if you take C section, now tell me, guys, is it symmetric? And it is symmetric about what? It is symmetric about x axis. So again, in this case also, your product moment of inertia will be 0. Okay, and if you have a doubly symmetric means suppose you have a I section. What is it? Is symmetric about what? It is symmetric about both the axes, right? So it is known as doubly symmetric cross section. Okay, so whenever there is a symmetry, at least one symmetry, your product moment of inertia will be 0. Now again, this is very important note. All your inertia must be calculated about centroid. Okay, as neutral axis passes through centroid, or you can say all your inertia must be calculated about centroidal axis. Centroid, or you can say about centroidal axis. Okay, fine. Now, guys, the next. There is something called parallel axis theorem. Have you guys heard about this parallel axis theorem? Right? Where it is important? Guys, you may know inertia about one axis which is not centroidal axis. Okay, suppose I have a cross section, and for this cross section I know my inertia about this origin. Okay, or my global coordinates. These are my global coordinate. I know my inertia for the given cross section about this ox oy axis. Now I know this is my centroid, and my the centroidal axes are what? CXC and CYC. So how I can find? You want me to zoom? Okay. Anyway, I am going to provide this. One thing I am doing actually, I am erasing also. I can save also at the end. Okay, I'll try to make that habit not to erase whatever I write. Right now we have an option. If at the end of the class we provide in chat, it will have all the annotation, right? Like other teachers are providing. But I have that habit to erase. Okay. So for my classes, you need to recap. Then only you can make good notes. Okay, or you have to take notes side by side. So this is clear. Now, guys, suppose you know already your inertia is about some global axis. Okay, here my ox oy is global axis. So using parallel axis theorem, I can find inertia about centroidal axis. What is the requirement? My centroidal axis must be parallel to that global axis, or above, or those axes about which you know inertias. So what is the distance between this cxc and ox? It is y. And what is the distance between oy and cyc? It is x, right? So what will be your ix cxc? It will be what? Ixx plus a y square. Okay, the distance between two parallel axes. What will be your I y y? See, it will be I y y plus a x square. Okay, when we solve the question, you guys will understand in a better way. So I'm just covering all the concepts. Now, what is your I x c y c? It will be I x y plus a x into y. Okay. So this is parallel axis theorem. You guys might have learnt this in your basically you guys might have learnt this in what, uh, engineering mechanics, right? Okay, so next, transformation of moment of inertia. Okay, so if you take Maxon problem, Pragati, you guys have learned this, right? Thin wall structure, right? If you solve this Maxon question, definitely you need to know these concepts. Okay, so let's move. Yeah, transformation of axis. Now, guys, you already know. Suppose I have one section, like you take guys, just a moment. We have a sections like okay, this kind of section. So I have an inclined section. Okay, now guys, I know inertia about what, if you take these two sections, right, 1 to 2 and then 2 to 3. So for 1 to 2, about which axis you guys know inertia? Can anyone tell? We will be knowing inertia about this axis, right? Considering it's a simple regular shape, right? So but you want guys what, inertia about this axis. So how you can find the inertia about that xx? Using transformation, right? So how many of you remember stress transformation matrix? Can anyone tell stress transformation matrix? How many of you remember stress transformation matrix? Hmm? There are two matrix, right? One is what, c square s square 2cs, s square c square minus 2cs, then minus cs, then c square minus s square. Now tell me guys, this matrix is applicable when? How many of you are aware about this matrix? Yes or no? Yeah? No? Means you guys not have learnt this as well? Parth, you have joined long back. Chinabasa, why? Chinabasa? Agam, you don't know? You are learning second time in IGC. You guys have not used my notes. I think sir also have covered, right? Rahul sir has covered, right? This transformation, stress transformation in matrix form, right? No, no, no. It's not plus. No, don't guess Sahil. It's minus CS, then CS and S square minus C square minus S square. So this is first transformation matrix. And here guys, this transformation matrix is generally valid if theta is measured in which direction? theta is measured clockwise. Okay, this is valid when theta is clockwise. What I mean, if this is given and your unknown is making some theta angle, then this matrix is valid. Huh? Why anti-clockwise? Okay. Yes, anti-clockwise. Right. It is not clockwise. It is anti-clockwise. Okay. Sorry, guys. You guys are correct. Theta is anti-clockwise. Okay. So what it mean in this case? What I will come to know? Sigma x, sigma y, and tau xy, and it in form of what? It in form of sigma xc, sigma yc. Okay, and then what? Tau xy. Okay, so you guys go and read transformation matrix. This is first matrix. Now guys, what you see here, my known are in inclined, right? So here theta is what? Clockwise or anti-clockwise? In this case, theta is, see, your given are in inclined, right? So theta is clockwise. So when theta is clockwise, what you guys have to do? You have to substitute here minus theta, minus theta. When you substitute that, what is going to happen? When you substitute minus theta, your transformation matrix will become what? C square S square minus 2CS, then S square C square 2CS, and then CS minus CS, C square minus S square. Clear na? Pragati, this is correct, yes or no? This is the second transformation matrix, yes or no? Correct, right? Everybody agree? Is it correct? Right? So you can see here my cross sectional properties are given in inclined axis, in inclined plane, right? About ix and iy. So I have to use this second matrix, transformation matrix. See, your inertia transformation is exactly like your stress transformation. Okay, so what, my unknown is ixc, xc, iyc, yc, and ixc, yc. This will be equal to this into multiplied by what? Ixx, iyy, and ixy. Is this clear? So those who are not knowing this transformation matrix, I request you all to go through the lectures, okay, done by Rahul sir. Transformation of stresses. Clear? Now you can see, I can simplify. You multiply c square ixx s square iyy minus 2cs ixy, then s square ixx c square iyy, then 2cs ixy cs ixx, then minus cs iyy plus c square minus s square ixy, where c is equal to cos theta and s equal to sin theta. So this is about transformation of moment of inertia. Now the main thing comes. We need to find cross sectional properties for this given below section. Okay, because from here the calculation part start. Okay, so guys, you can see what it's an L section. So what is the first thing when we find cross sectional property? What we have to do? We have to define one origin, right? Reference. So my, this is the reference axis, O, X, and Y. Clear guys? You always need to define what? Reference axis. Now guys, we will make a table. Before that, this is what? Is it a regular section? It's a symmetric section, or it's non-symmetric section? What it is? It's a non-symmetric regular section, right? So whenever there is a non-symmetric regular section, what we do? We can use which formula? Summation formula, right? We can use summation formula. So for summation formula, what we have to do? We have to divide this section in multiple part, right? To make it symmetric sections, right? Multiple symmetric section, right? So you can divide, right, this L section in whichever way you want, right? How you can divide? Either like this or like this, right? So you will have two what rectangular sections, right? So which way you guys want? Like this, right? So when you divide this L section into rectangular section like this, what will be this dimension, guys? What is this dimension? It will become 90, right? So there are two sections, right? Okay. And what was your reference axis? We have defined reference axis, right? Like here, it's a origin, and like this is x and this is y. Okay, so first thing what we are going to calculate, centroid. So how you can calculate centroid, guys? We go section wise. So we have two section, right? Section, this is section 1 and this is section 2. Now guys, for section 1, first what you have to find? Xi, and then you have to find yi, then you have to find areas ai, then xiai, and then yiai. Clear about this table? So for section 1, this is my section 1, guys. This is my section 1. Now in this section 1, guys, tell me what is your xi? What is the position of xi? If you draw this section outside, it is better we draw here, right? Now if you see how we can find xi yi position, like this, match the diagonal. So this is the point, okay, centroid of this section. So what will be the xi? You will have this position, right? This much. So this value is how much? 5, right? From origin this value is 5. Everybody, is it clear? So my xi is 5. Now why, what about this yi? You can see this distance is how much? 45. But from origin, from here, this is what? 45 plus 10, right? From bottom it is how much? 45 plus 10, so it is 55. Now for section 2, section 2, if you draw here, this is my origin, okay. Now section 2, what is the xi? This will be your xi. So how much it is? 50, because total is 100, right? This is 100, right? Now guys, what is your yi in this case? This is again origin, so this distance is how much from origin? It is 5. Now guys, what is the area of section 1? What is the dimension of section 1? It is 10 into 90. So what is the area? This is 10, and what is the height? It is 90. So area is 900. What is the area of section 2? It is 100 into 10. So it is 1000. Now guys, find out xi and yi. So xi yi is what? 4500, and this is what? 50,000. Okay. Now yi YI AI is how much? Double zero nine five so 45 5 49 49,500. Now what is this YI AI for section 2? So it is 5,000. Now find guys summation of areas and summation of XI YI. So what is the summation of area? It is 1900. Then how much this? 54,500. And I think this is also 54,500. So guys, now we know what is the XI. XI is sigma AI XI upon sigma AI. Right? Same way. What is the YI? It is sigma AI XI upon, sorry, not XI, sigma AI YI upon sigma AI. So guys, tell me what is the value XI and YI values? Yes, it is 28.64, 28.64. Okay, so what is the XI YI? Your XI or not XI YI. What is the value of not XI Y? Better, guys, X bar Y bar. We did not X bar and Y bar or XC YC. So in this centroid is what? XC equal to YC. Okay, on it is coming as a how much? 28.64. Clear everybody? Is it clear? This centroid calculation is clear? Okay. Everybody, is it clear? It's not that tough. I have taken very simple L section. Okay. Just I want you guys, Ashish, you have put thumbs down. Huh? Why? In your profile, you have put thumbs down. Huh? You should be thumbs up. Okay. Anyway. So once you know centroid, right? Just a moment, guys. Yes, guys. So you guys know centroid, right? Now, guys, next is what we have to find what IXX. Okay, or you can say IXC, then IYC, and then IXC. How you can find, guys? Again, you have to make a table, and you have to use what? You guys have to use what? Now, if you look this section, you know centroidal position from where, guys? You know from this point, right? The position of centroid, right? Somewhere here, right? Yes or no? So you have to find your inertias about this XC and YC, right? So for this, again, what you have to do? You have to find first what first is what your section. Okay, section is 1 and 2. then what, I xx, then I yy, then then guys what, ai. Now guys, one thing I want to know, when you find the distance, right, parallel axis theorem, okay, you know what this position, right? So is this your y distance in parallel axis theorem? No, right? This is not the y distance. If you take this section 2, so what is the y distance? This should be this y distance, right? Exactly, yes or no? So what it will be? It will be what? Anybody can tell what it will be? This distance will be what? Yc minus yi. Am I correct? Square. Now guys, one thing you always guys remember. Sometime people write what? Sometime people write yi minus yc. If you write yi minus yc, then in this next column you have what? Ai xc minus xi. Okay, understanding my point guys? You follow the same sequence. If you are writing yc, then you have to first write xc without any confusion. Otherwise your calculation will be wrong. For which case the calculation will be wrong? Can you tell anybody? And here, for which case the calculation will be wrong? Not for z section guys. If you reverse it now, your product moment of inertia will be wrong. Okay, so guys, here there is some stray space constraint. Okay, okay guys, let me do this one thing. Okay, I will write bit small. Okay, so what I should write first? Ai, so it is yc minus yi square, then ai x c minus xi square, then ai yc minus yi. Then what should I write guys? If I write yc minus yi, then what should I write? It should be next xc minus xi. Clear? Clear this point guys? Now one more thing I want to ask guys, in this table, why I have not written ixy? Can anyone tell? In this table, why ixy is not present? Ajay, Amit, Agam, Rishika, why ixy is not there? Srujana, real, why ixy is not there? Pranita, in this table, why ixy is not there? Hmm? Not this, I am not you asking you. I'm asking other people. Vikas, Venkatesh, Sri Krishna. Why IXY is not taken in this table? ixx iyy, you know, right? Ravitesh, I didn't ask you. Yes, because this individual section 1 and 2, right? This section 1 and 2 are symmetric section, right? Clear na, Pranita? These are symmetric section. Individual section are symmetric. Yes, Rishika. That's why ixy are 0. But if you take the whole L section, it is not symmetric, because here we will see non-zero quantity. Now guys, let's fill the table. So what is the ixx for this section 1? We have taken this section 1, right? So for what is the ixx? bdq by 12 or dbq by 12? In engineering mechanics, right? Again I am writing somewhere. Okay, let me see the space. What is the ixx for a simple section? Suppose this is B, this is D. What is ixx? It's a bdq by 12, right? Or dbq by 12? It's a bdq by 12. So what is the B? B is 10, right? What is the D? D is 90 q by 12. Okay. Now guys, what is the IYY? What is the IYY? It is 90 into 10 cube by 12. Okay. Mhm. Now guys, what is the IXX for section 2? For this section 2, what is the B? B is 100, so it is 100, and depth is 10 cube by 12. Then it is 10 into 100 cube by 12. Okay. Now guys, areas. Area, we know what is the first section area. Area of the first section is 900. So it's a 900. Now what is the YC? YC distance, it is 28.64 minus, what is the YI? What is the guys YI? It is 55. So 55 whole square. Second, it is area is 1000, then 28.64 minus, what is the YI? In the second case, it is 5. So it is 5 whole square. Now again, area is 900, then it is 28.64 minus, what is the xi? It is 5 square, then it is 1000 into 28.64 minus, what is the xi? 50 square. Now guys, you have to multiply ai into yc minus y into xc minus xi. So simple. You guys can multiply this into this directly. Okay. Square is not there in here. You have squared, so let me write. It is 928.64 minus 55 Okay. I think one message is popping. So guys, you can fill this table, right? Yes or no? Because here some message is popping. Let me write next here. In the one page, I have limitation. Okay, so I'll do one thing. Okay, let me write now. So it is minus 55 into 28.64 minus 5. Then second, 1000 into 28.64 minus 5 into 28.64 minus 50. Okay, so this table is complete, guys. Yes or no? Now what you guys have to do, you have to find the summation of all these quantities. Okay, once you find the summation, what is your ixc is what? Summation of ixx plus summation of ixx plus summation of ai into yc minus yi square. Clear, guys? Is this clear? Same way, you guys can write I YC YC and then I XC YC. I XC YC. So guys, find out these values. Now tell me guys, in industry how these calculations are done. Can anyone tell? In industry how we do this calculation? Akash, are you there? Programming is there, but usually in Excel. Okay, there are tools also. If you take Airbus, there are tools like Isami. If you take many other companies, they use Excel, Microsoft Excel. Okay, so in Excel there are formulas. We can have automated formulas. Just you need to put, uh, dimensions, then we can find this cross sectional properties. Okay, by calculating with hand, though we call hand calculation, but we don't write anything on paper and do. Clear, guys? Akash, you know, right? Hand calculation doesn't means you write on paper and do calculation. Hand calculation means you use the basic SOM approach and you solve the problems. Okay, that is what hand calculation. Ajay, you also aware of this, right? Okay, so guys, tell me what is the ixxc iyyc, both should be same, I believe. Okay, and then ixc iyc may be negative. Tell me the values, guys. Anybody could find the values? Okay, so Disha, it is 18 point triple zero four seven 10 to the power 5. Or so others also, please check. Yes, correct. So IXXC is no Pranita. I think your both should be same. Instead of 179, you might have done some approximation. IXXC and IYYC should be same in this case. Okay, check your calculation. So it is how much we are getting? 18 triple zero 18 triple zero 47.56 power 4. Okay, now IXY is negative or positive? Pranita, it is negative or positive? Your IXX and IYYC is same. Yes, Pranita, take care of sign. It is negative. So how much the negative value? It is minus 1065785 power 4. 0.76 power 4. So everybody, is it clear? Everybody, is it clear how to find these cross sectional properties? Okay, yes or no, is it clear? Okay, so guys, one more thing I want to tell. Sometime people write these in 10 to the power 5, right? When you write this quantity in terms of 10 to the power 5, what you need to take care? Can you tell me? When you write this quantity in 10 to the power 5, what you have to take care? You have to write your quantity up to 4 decimal. Like if you write this minus 1.065785. Okay, so you have to write to more decimal. Otherwise, what will happen? There will be error in your answer. Okay, so always take care. If you write this quantity in this form in 10 to the power some numbers, like it is 10 to the power 6, right? Yes or no? 10 to the power 6, right? It is. Then you have to write in more decimal. Otherwise, your answer may not match in the given range. So that's what. And so this is how we find cross sectional properties, guys. For considering exact dimension. This is considering exact dimension of the given structure. Now, guys, there is another thing which you need to learn in thin walled structure is what? Approximation of thin walled sections. Guys, anybody know how the approximation is done? So in approximation, how it is done? A thin walled structure is always drawn on what? Midline of the section. It is thin walled structure is always drawn on midline of the section, and in calculation of area moment of inertia, higher order terms of thicknesses are neglected. Clear? So this is what approximation of thin wall section. See, we have calculated cross sectional properties using exact dimension. Now we will calculate cross sectional properties using the given section as a thin wall section. So first guys, this was the given section, right? This was the given section, L section. Okay, exact dimension. So now if you consider it as a thin wall, not mean area, Pragati, we draw it on mean line. It is not mean area. Means, see, if you take this, suppose this is simple rectangle, thin rectangle, right? Thin rectangle means what, Pragati? This thickness is small, right? This, so it will be drawn on midline, or you can say this is like this. Okay, so how we do, this will be your thickness and this is what your depth. Okay, but now there is a L section, right? So where these mean lines are meeting, somewhere here, right? Clear? It's visible to everyone, right? So what happened, when you draw it as a thin section, your dimensions got reduced, right? It is not exactly 100, you can say it is 95, 95, but your thickness remains same. So there is some change in what, there is some change in what, width of the section, right? Or depth of the section, yes or no? But your thickness remain same. So this is what your thin walled assumption, or you draw, that's how thin walled section. Now guys, I will do one more thing. I will show you guys one more section. Okay, you guys have seen one of the gate problem. They have given one hollow square section, right? They have given hollow square section, and this is a torsional problem. Anybody has solved this pyq previously? There is a square hollow section and they have given these outer dimensions and inner dimension. Now guys, when you convert it to thin walled, what will be your dimensions? Can anyone tell? What will be your final dimension? My final dimensions will be this. And if you are not using this dimension, your answer will not be in given range. Okay, so that means if you take your section out as a thin walled, it will be drawn like this. Still your thicknesses will be same. It was like T1 and it was T2. Okay, but what it will be guys, suppose this is X, so what will be this? Can anyone tell? It will be X minus, can anyone tell what it is? X minus, what it is? X minus 2. It is X minus T2, because it's a half half, right? T2 by 2, T2 by 2. So it is T2. Clear now? See this, guys, half on both the sides. This much, and here also this much. So it is X minus T2. Now suppose this is Y. So what will be this final, guys? What will be this final dimension? It is Y minus T1. So this is Y minus T1. So you guys understanding how this thin walled approximation is done? Is it clear of for any section how we do this thin walled approximation? Clear? Yes or no, guys? Others, please respond. Punya, Yuvraj, Shivani, Shivam, Udaykant, Abhishek. Please answer the poll. Everybody, please answer the poll. Okay, so this is what your thin walled approximation. Okay, so in this thin walled approximation, guys, this is how we write the final dimensions. Again, now for this thin walled section, this is my thin walled section, right? This is what my thin walled section. Now, guys, for this thin walled section, you need to find again cross sectional properties. So first find centroid. So now how many section you have? This is section 1 directly, this is section 2. Now, guys, still when you find the centroid you need to take what? Reference, right? So I'm taking my same reference. I'm taking this also, still this origin as my reference. Okay, so where it is? It is somewhere, right? Yes or no, guys? Agree? This my reference axis. Is it clear? Everybody, is it clear? Reference axis? Yes or no, quickly? Okay. Now, guys, draw a table. Quickly draw a table. So, section 1 and 2. What is your xi? What is your yi? What is your ai? What is your aixi? What is your aiyi? So for section 1, what is your xi? It is 5. What is yi? It is 5 plus 42.5. See, 95, right? So what it will be? 42.5, and then below this is 5. So how much? Yi is how much? 47.5. Now, guys, for section 2, what is the xi? You know, right? Xi again, it is 42.5, and again you have a distance of reference 5. So how much? It is 47.5. If you take yi, what is the distance from reference? Vertical distance, it is 5. Clear? Now what is the area? 950. 950. Now multiply, guys. So you guys find 5 to 47, 4750. Okay, then this is 4750. How much this ai guys, can anyone tell? AIYI. No. See, I am taking Sam. I can take anywhere, Srujana. I can take anywhere, but I want to keep Sam just to, compare. Key from Sam point, is there any change in centroid position if you consider thin wall? Srujana, reference you can take any, but I am taking Sam just to compare. Yes, so AI into YI is 45125. This is 45125. Okay. Oh, sorry. Yeah, 47. It is, sorry, 95 divided by, yes, that's mistake. See, this kind of silly mistake happens. It is 47.5. This is also 47.5. So, is this correct or wrong? That is correct or wrong, guys? Hmm? Anyway, I got, see, this kind of mistake, silly mistake happens, guys. So, this is not correct, right? Okay. So, let me erase this. Okay, fine. Thank you, guys. So, guys, be careful. Silly mistakes happens. So it is 52.5. This is 52.5. Don't just believe me blindly, guys. Okay. Then AIYI is how much? 49875, and it is 49875. Okay. Now, guys, find the summation. Once you find the summation, what is this 54625? Is this table not correct? Or summations? Fine. The summation, right? So it is, yeah. So it is 5 4 625, 5 4 625, and this is 950 plus 950 is 900, 1900. So, guys, tell me, what is your XC and YC? Both will be same, right? And I think approximately it will come same, right? So previously also we got 28.64. Now it is coming 28.74, right? So approximately we are finding similar value. So here there is not much difference. But when you find area moment of inertia, there will be slight difference, okay, in this case. But if you do later, what? Idealization, boom idealization, there will be more variation. So everybody, it is clear? Xi by I, can I move further? Okay. Now, guys, we need to find area moment of inertia. So area moment of inertia, guys, it is x, the section. So section first. So section first, right? Then ixx, iyy, then AI, then YC minus YI square, then AI XC minus XI square, then AI YC minus YI into XC minus XI. Clear, guys? So draw this table. Now, guys, in this table, if you take section 1, and then section 2. For section 1, what is your IXX? Can anyone tell? For this section 1, what is IXX? It's a BDQ by 12, right? Yes or no, guys? So it is a BDQ by 12. What is the B? It is 10. What is the D? It is 95. So it is 10 into 95 cube by 12. What is the IYY? It is 95 into 10 cube by 12. Now, guys, what is the thin wall approximation? What is the thin wall approximation? IYY will be what? IYY will be what? Neglected. This will be neglected from solution. This will be 0 because we don't consider higher order term of thicknesses. Okay, clear? Now for section 2, what is the IXX? For section 2, what is the IXX? It is 95 into 10 cube by 12. Okay, so it is what? 95 into 10 cube by 12. Again, this is neglected from analysis. So what is the IYY? It is 10 into 95 cube by 12. Okay. Now AI, so 950, then 28.75 minus, so what was the YI? 52.5. So 52.5 square. Okay, then 950, 28.75 minus 5. Again, what silly mistake people do, guys? What silly mistake happens here, guys? Sometime instead of YI, people write XI. Okay, so that kind of mistake happens because we have written in first table xi and then yi, but in this table, why I have written this first, guys? Can anyone tell why I have written this first? Because this is associated with ixx in parallel access theorem, right? To find ixc. Okay, now, guys, what next? 950 into 28.75 minus 5 square, and this is 950 into 28.75 minus 52.5 square. then 950 into 28 point multiplied by, and same. Here both the terms are same. Okay, then rise guys, find the summation. Once you find the summation, your ixc is summation of ixx plus summation of ai yc minus yi square, then I yc guys find out, then I xc yc. Do this guys quickly. Okay, ixc Sam, it will be Sam. Yes, I. Both will be Sam. So you can see the earlier and this some difference is there. Earlier you can say 1.8 something. Now it is 1.78. Okay. In Sam 10 to the power 6. So IXC, IYC is there na. This will be summation of AI. This will be summation of AI into AI into your yc minus yi into xc minus xi. Okay, xc minus xi. Clear? You know, right, Shivam, why don't we find ixy? If you take individual section, are those symmetric or not? So the same logic, right? Shivam, why don't we find ixy for individual section? Because those are symmetrics, right? Okay. So this is clear, everybody? Is this clear? Thin walled approximation and how to find the cross sectional properties. Everybody, yes or no? So clear, guys? Everybody, it is clear, right? Now let's move to next, which is what? Boom idealization. So first we discussed thin walled approximation, and now thin walled idealization. What is thin walled idealization? So this thin walled idealization is also known as boom idealization, or lumped areas. Okay, these boom are what? Idealization. Okay, so this is known as boom idealization or lumped area idealization. So why this is required? You all know, right? What is the wing cross section? It's a aerofoil cross section. So is it regular shape? And it's a thin walled section, right? Yes or no, right? So if you want to find cross sectional properties using analytical method, can you find using analytical method? It's not possible, right? It's not possible. So in early era, when computers were not there, right? When computer was not there, that time this boom idealization was used to find centroid positions and cross-sectional properties of aerofoil kind of sections. Yes or no? Clear? How? If you convert this aerofoil section in multiple boom, okay, what is the advantage? Suppose you take your reference here, right? I can find the position of each boom, right? Yes or no? From that reference, yes or no, guys? You can find the position of each boom from that reference. Now what is this boom? That is what you guys will ask, right? Once you know this position of the boom, you can find, approximate the position of centroid. Now what is these booms, guys? How you find these boom areas? How you guys find this boom area? So let me make you guys clear how you find these boom areas. So guys, if you take this section, okay, for this section you can see there are two boom, right? So what we do, can you find this area of that section? What will be this area? Suppose S is my length and T is thickness. So that will be my area of that section. That thin section area, clear na? This is S and this is T. Thickness is T and S is the section length. Now what, when we do boom idealization on both the booms, means what? You have two booms, right? One boom. So we will divide these areas equally. We will divide this area equally on both the boom. So it will be what? Suppose this is A by 2. Okay. So this will be A by 2 contribution. Here also A by 2. Now guys, on this boom and this boom, there is a contribution from this section also, right? So suppose initially you took that A1. This is A1, this is A1. Second it was A2. So here in this boom, what will be? It is A1 by 2 plus A2 by 2. Now this is A3. So in this boom it is what? It is A3 by 2 plus A1 by 2. Is it clear how these lumped areas are calculated? Yes or no, guys? Now same way on this, suppose it is A4. So what will be this area? This will be A3 by 2 plus A4 by 2. Everybody, how we are doing boom idealization, is it clear? First you need to find the section area, and then you have to distribute that area equally in the respective side boom. Okay, yes or no? So this is how, thin walled idealization is done for any curved section. Now again we will do what? We will take our L section. We will take our L section and we will see how idealization can be done. So my thin walled L section, it is same. Clear guys? The dimensions are same, 95, 95, and thickness is 10. Now guys, here I assume this is 1 to 2, 2 to 3. So my section 1 we took now. My section 1 is here what? It is 1 to 2, and my section 2 here it is what? 2 to 3. Clear everybody? Is this clear? Now for section 1 to 2, what is your area? It is A1 and it is what? L into T. So what is this L into T? It is 95 into 10. It is 950. Now what is the section 2 to 3 area? It is again L into T. So it is 95 into 10. It is 950. Now guys, my section 1 to 2, this 1 to 2 I am dividing in 3 boom. I can divide in any number of boom. More the boom, more will be accuracy. Okay. You take more the lumped area, more will be accuracy of the calculation. So I am taking 3 boom. Okay. B1, B2 and B3 1. So what will be the area of each boom? It will be B1 equal to B2 equal to B3 1 equal to A1 by 3. Why I have taken B31, can anyone tell? Because here this is the common junction. So here the contribution will come from 1 to 2 and 2 to 3. Same way 2 to 3 I have divided in 3 boom. So again it is what? B32, B4 and B5. Now what is the areas? All are A2 by 2. So A1 by not 2. It is A2 by 3 and it is A1 by 3. Okay? Yes or no? Is it clear guys? Till now any doubt? Okay. Now guys, when I combine this section 1 and 2 and 2 to 3, my idealized section looks like this. So here you have a bigger boom. You have a bigger boom because there is a contribution from 2 to 3, as well as there is a contribution from 1 to 2 and 2 to and 2 to 3, right? At the common junction. So you can see B3 is a bigger boom, and which is what? B3 is what? My B3 boom area is what? B31 plus B32. Clear? Clear guys? Yes or no? Okay. So guys, now you can see B1, B2, B3, B4 and B5. Now guys, what is B1 equal to B2? Already we know. What is the A1? It is 950. Hello? Yes, guys. Sorry. Okay. So, Devadatta, you are asking me to repeat, right? So, at common junction, see, this is the two is a common junction, right? So there is a boom from 1 to 2 and 2 to 3, right? So 1 to 2, what is your boom? B31. And from 2 to 3, what is your boom? B32, right? So at this junction, you have a bigger boom. Clear? Okay, right. Now what was the B1 and B2? It is 950 by 3, right? What is the 950 by 3? 950 by 3 is how much? Approximately it is 367, right? Yeah, 316.7. So you can see here boom B1 will be 316.67. B2 is also same. B3 is what? B3 is 2 into 316.67. Then B4 is also same, 316.67, and B5 is also same, 316.67. Okay, so these are the lumped area or boom areas. Now guys, you have to find cross sectional properties. Here there is a typo, guys. Here there is a typo. This is A1 by 3, A1 by 3, and this is A2 by 3, A2 by 3. It is A1 plus A2 by 3. Okay, clear, guys? Is this clear? Yes or no? A1 by 3, A1 by 3, then A1 plus A2 by 3, A2 by 3, A2 by 3. Now we have to find again cross sectional properties. So, first, what we have to find? Centroid. Okay, centroid. So how you find centroid? Now here instead of section you will have booms. Okay, so you have boom 1, 2, 3, 4, 5. Now what is your xi and yi? Again guys, one thing you have to do, you have to again fix the reference position. So my reference is still same. You can say my reference is still same. Okay, which is at what? 5 distance up and down from boom 3. Okay, means the coordinate of B3. What is the coordinate of B3? It is 5 comma 5. Now guys, tell me the position of B1. What is the xi position? 5. What is the yi position of boom 1? What is the yi position of boom 1? Can anyone tell? It is 100, right? 95 plus 5. You can see this is 95. So what is the position? Yi. It is 100. Then for boom 2. For boom 2, I think it, what is the x? I 5. What is the yi? 52.5. Okay. Then section 3. What is 5? 5. Not section. It's a boom 3. 5 comma 5. Then boom 4. 52.5. Then 5. And then 105. What is the areas? 316.67, 316.67, then 633.34, then 316.67, 316.67. Okay, then you guys find out xi yi, and then not xi yi, sorry, it is xi ai, and then yi ai. Okay, so guys, once you find out, do the summation. Do the summation. Yeah, so it is coming 28.75, right? So it will come same, both will come same. xi, yeah, sorry, xc, it is 28.75. Okay, and yc is also 28.75. Okay, now guys, one thing we need to understand before proceeding: area moment of inertia. So in case of boom, what will be your ixx? Anyone can tell? Iyy and ixy. In case of lumped area, the area moment of inertia about its own axis are what? Zero. For lumped areas, the area moment of inertia about its own axis is what? Zero. Okay, clear? Means if you take about its own axis like this here, your ixx, iyy and ixy will be 0. Okay, for lumped areas, I will write in that also. For lumped areas or boom areas, for lumped areas, for lumped areas, area moment of inertia about its own axis are 0. Its own axis are 0. Is it clear, Shivendra Raj? Okay, so now when we find area moment of inertias, area moment of inertias, first your booms, in table you get booms, then next will be ai into yc minus yi square, it will be ai yc minus ai xc minus xi square, and then ai yc minus yi into xc minus xi. Okay, clear guys? So what is this? Boom, 1, 2, 3, 4, 5. Now what will be your ixcxc? It will be summation of ai yc minus yi square. What will be iyc yc sigma ai xc minus xi whole square. And then what about ixc yc is summation of ai into yc minus yi into xc minus xi. Clear guys? Okay, clear? So guys, you can do this table. Is this clear? Yes or no? Because I need to cover some few small concepts. So how was the class guys? Was it clear? Everything was it clear today? It is more about process and mathematics, but we have gone step by step from basics, centroid, area moment of inertia for actual dimension, for thin wall approximation, and for boom idealization. Okay, so this much is only required for your gate exam point of view. Okay, now, and even in gate exam, they will not ask to find. Many times they directly give cross sectional properties, they give. In TSG magazine you can't easily understand. Okay, Sivendra Raj, uh, we learned like this only from our peers. Okay, my teacher was Mohidin. Mohidin sir is now tech lead, I think, in um earlier he worked with G Aviation, and now he's, I think, in Vestas. Okay, so he was my teacher. Okay, so now once you know that boom idealization, we have two more concepts in this cross sectional property. Already we have discussed the moment of inertia for inclined section. So we have to do what? We have to do transformation. So suppose my inclined section, I have told, I know this, right? This is my section of length a and thickness t. Now I know my inertias in this axis, right? If these are my x and y, I want my inertia about this x bar, y bar. So first, what I know, my ixx is what? Atq by 12. Okay, atq by 12. Since it's a thin wall, we need to neglect. Then iyy is what? Taq by 12. Okay, now guys, ixy will be 0 because it's again a symmetric section. It's a incline, but it's a symmetric section, right? So ixy is 0. So now transformation matrix, what it is? C square s square 2cs, right? So you can see c square s square, and I think first is minus 2cs, if I remember. transformation matrix, it is minus 2 CSE, okay, into IXY. So this is already 0. And IXX is 0. So what is my IXX bar? It is TAQ by 12 into sine square theta. Okay, same way Iyy I can find, and I can find Ixy bar or Ixcyc. Okay, this is how, in this is 0 and this is minus. So you can, it is 28, I think it should be CS, not 24, 12, so 24, not 14, it is 24. It is 20 24. Okay, it is 24. Now, guys, this is about inclined section. You guys can look into, if any doubt can ask me in next class. Now next and last is what, moment of inertia for curved section. So you can see this is a curved section. Okay, and for this, suppose you want to find Ixx, moment of inertia about this. So for what you have to do, this radius is R, radius of this section is R. Okay, and this is make, we took this section here which is making theta angle from vertical, and this section is ds. So what will be your Ixx? Your Ixx will be what, this distance. So it is integration this distance y square dA, right? Now what is the y? It is r cos theta. So it is r cos theta square. What is the dA? It is tds. So it is r cos theta. Yes, I will go to previous slide. Don't worry, Pragati. It is t ds. And from where it is integrated? 0 to pi r. Because this length is what? Pi r. Now we convert ds in theta. So ds is what? R d theta. So this limit will become 0 to pi. So it is 0 to pi r cos theta square t r d theta. Now when you change here, it is become r cube t 0 to pi cos square theta into d theta. So what is the integration of this? It is pi r cube t by 2. So this is how we find for curved section moment of inertia. Now you want me to go to previous slide. This is what your previous slide. Okay, clear? This is done. Okay, now guys, I am giving some homework. So guys, do one practice. Take one channel section. Okay, channel section. So this is 100, this is 50, this is 50, and this is 5, this is 5, and this is 10. Find out, you do for all three. Okay, all three. First, actual dimension, then, or let me draw it. Okay, let me draw in that way only. You guys do with all three. Okay, so let me draw like this with actual dimension. Okay, so this is 5. Okay, let me give the easy value 5. This is also 5. 100, and this is 50. Clear? So this is one homework. Second homework, this Z section. So this is 50, this is 50, and this is 100, and this is 10. Guys, can you do this? Can you guys do these homeworks? Yes or no? So that's all from my side in today's class. And let me know if any doubt next class. Okay. Hopefully everything is clear. Everything is clear. What you have to do, Amit? $1 million question. You tell me what should I do for this section? What we learned today? Huh? What you have to find? Find out cross sectional properties. All three cases. Okay. All three cases. First, actual dimension, thin walled approximation, and thin walled idealization. Clear? Amit, what to do? And you guys have to share this. You guys have to share in a group. All of you have to share. Okay? This is homework and strictly it need to be done. Clear? Yes or no, guys? Before next class, it must be done. Hopefully, next class will be on Wednesday. All of you must complete this exercise for these two, then only you will never forget these concepts. Okay, I can also do some silly mistake, you can do silly mistake, but you should not forget concept. Okay, how to find cross sectional properties. Clear everyone? Okay then.